So at the top of page 199, it has this combining transformation box with stretches, compressions, and reflections, and saying they could be combined. You could have y equals AF of BX, where A and B are numbers. And in this box, I think they actually make it a little bit more confusing than they need to, so we're going to try to clarify it a little bit. First of all, we have an A outside of the function. Because it's outside of the function, does it make sense that that A is going to affect your y values? It's going to do something vertically. And everything that's been vertical so far has been exactly as you would expect. So in this case, with that A, you're going to multiply y by whatever that A value is. With the B inside the function, that's going to be horizontal. That's going to affect your x values. And so that B, we're going to multiply our x value, but instead of multiplying by B, we've noticed that everything inside the function has kind of been the opposite of what we would expect. Left and right are different signs, and with multiplying, we don't multiply by B, we multiply by the reciprocal. Whatever that number is, you'd multiply by 1 over that number. So if it was 3x, you'd multiply by 1/3. And I think we even had one example in our homework where it was a fraction like 4/3 or 3/4, and you had to flip that fraction, and then even your answers weren't very nice. Okay? That happens. Lots of times our answers end up with fractions not as nice numbers. So I think this is easier than they tried to show it as the point. Can you see that they took the y value and multiplied by A? That's why it's AY. Can you see that they took the x value and multiplied it by 1 over B? But I think this technique that we've been using helps explain it a little bit clearer. But if you want to remember A, that's easy to say and remember, perfect. Maybe not. Okay, let's look at example 3. Example 3 is our first one where we are combining. We're given things in function notation. There's the graph of f of x. We need to sketch the graph of y equals 4 f of negative 0.5x. And then state the domain and range. I'm going to start using some abbreviations. That 4, horizontal or vertical? Vertical. Are you okay with the letter V for vertical? Is it going to be a stretch or compression? Stretch, because we're multiplying. We're going to be multiplying y by 4. Anytime you're multiplying by a number bigger than 1, that will be a stretch. Okay? The negative, horizontal, because it's inside. The negative, reflection. Are you okay with R for reflection? And the 0.5, stretch or compression? Stretch. Why is it a stretch? Because we're going to be multiplying x by a negative 2. 0.5 is a half. The reciprocal would be 2. So that's why it's a stretch. So now if we're going to sketch this, we're going to take some key points on our original graph. Obviously, the most important point on this graph is negative 2, 0, because that's the starting point. Can you see that we also have negative 1, 1, and looks like 2, 2. Those are 3 points on our original graph. The technique that we've been starting to use is we draw arrows to show the transformation, and above the arrows we write what we're going to do to those points. Well, we wrote it out already. We're going to multiply our y values by 4 and our x values by -2. What's the result from doing that? Well, I'm going to get -2 times -2 is 4. 0 times 4 is 0. -1 times -2 is +2. 1 times 4 is 4. And -4 and 2 times 4 is 8. Again, the math is easy. You're going to find if you don't pay attention, you might multiply the wrong coordinate by 4 because it's so easy you stop thinking. So be careful. Then we've got our new points. We've got 4, 0. Draw a dot there. 2, 4. I'll draw a dot there. And -4, oh my goodness, 8. All right, just have to estimate that one. We have 3 dots. But we need to draw the shape of the graph. So a couple of things that are going to help us with that. We need to find out where we're going to start. I can join these dots in like bad ways. Here, like this, right? We have options. Should it be start here, go down? Should it be start here, go up? Should it be start here and then go like that? Those are all possibilities. I hope the last one is the one that you feel is least probable. Okay? Well, how do we decide which way it's going to go? One of those first two, you'd probably feel like, I think it's one of those first two. This was our starting point on our green graph, -2, 0. So it's going to be our starting point on our transformation. And if I know that's my starting point, now I can graph what's happened. Another thing that I do when I'm done a question, just to get a sense, have I done it right? Go through the words that I wrote. Has it been stretched vertically? Does it look like it's been pulled away from the y-axis? Flipped horizontally. Oh yeah, now it's going the other direction. That would be a horizontal flip would do that. And a horizontal stretch. Does it seem to be right? I don't know for sure, but does the general shape seem to appear right? Yes, with that horizontal reflection and some stretches, it appears to be right. Then we would know, okay, I think this is the right shape. State the domain and range of each function. For our first graph, the domain is the x values bigger than -2. I'll use the set notation this time. X is bigger than or equal to -2. And our range are the y values. Y is bigger than or equal to 0. For our blue graph, our domain, well, now it has no smallest value, but it goes up to 4. So x is less than or equal to 4. And our range has stayed the same. Y is bigger than or equal to 0. So we might notice that how have our y values been changed? They've been multiplied by 4. Does it make sense that when you multiplied 0 by 4, it stayed the same? So our range makes sense why it might have stayed the same. For our horizontal for our domain, our x values, they've been multiplied by -2. Notice how our domain changed. Instead of -2, I have +4. And because I've multiplied by the negative, instead of greater than, now it's less than. Underneath here, I'd like you to write question 3.5. Okay? And question 3.5, we are going to write the explicit equation. And in part A, I want you to write the explicit equation for y equals f of x. So first of all, a little review, because I've used this word a couple times, but it's still a word that causes some people problems when they read it on a test. What does explicit equation mean? Right now, this is in function notation. An explicit equation would just have y's and x's. So you'd have to actually say, I know what the real equation is for my red graph. What is my red graph's equation? What shape is it? It's one of the four that we looked at. Square root. What's happened to the square root graph? It's not here like it normally is. It's been moved 2 to the left. How do I show that? Okay. I'm going to do it in red because it was the red graph. Y equals the 2 square root graph with an x. But if it's been moved 2 to the left, I would have +2 in my equation. Part B. We drew the graph of y equals 4 f of -0.5x. Now we want to write the explicit equation for the green graph. And what this is really going to practice is your understanding of function notation. So up above, we wrote the explicit equation, y equals square root of x plus 2. Or, since that was what was equal to f of x, we could say that f of x is equal to the square root of x plus 2. And we want to write our blue graph, which was y equals 4 f of -0.5x. How do functions work? When I write y equals 4 f of -0.5x, I have something inside my function and something outside my function. If my original function is this one, wonderfully highlighted, then, wait for it, if I want to do this, it didn't highlight it. Nothing's working. So with our highlighted part, that is our regular function. Now, this 4 is outside of that function. 4 is outside of the function. Then we hit our function. Our function is the square root of x plus 2. But instead of writing x plus 2, what do I have now instead of an x? negative 0.5x. That's what a function does. If I put a 2 in there, you replace the x with 2. I put a negative 0.5x in there, I replace the x with negative 0.5x. So in the end, that's the equation of my blue graph. For students, working with function notation is one of the hardest things in this first unit, because you've done it before, but it was hard in grade 11 and grade 10. It gets confusing, especially when you start using x's. And when do I write function notation? When do I write explicit notation? We're going to make mistakes with this, but through practice we're going to get better and better. Now, I gave you the questions for this one already last class, 7, 9, and 10. Some of you have already worked on those.